Hi Algebra 1 students, this is Miss Penn. This video is on the zeros of polynomials. So we're going to start by just reviewing what we know about quadratics and finding zeros. And just so to kind of remind you guys, first of all, sometimes they're called zeros, sometimes they're called solutions, and sometimes they're called roots, but those are all the same thing. So just keep that in mind. It might ask you to find the roots, and you should think, okay, that means find the zeros. So to review, the zeros of a quadratic function graphically are the places where the graph crosses the x-axis. So we have our x-axis here. So it looks like we have a 0 at -1, and we also have a 0 at 6. Okay, now algebraically, we can also think about the zeros of a polynomial. So to start, I want to remind you that we have different forms of quadratic equations. So in standard form, we have f of x equals ax squared plus bx plus c. And in this case, I know that the standard form equation is f of x equals x squared plus, oh, oopsies, not plus, minus 5x minus 6. But we could actually get the factored form of this quadratic by thinking about how would we factor x squared minus 5x minus 6. So we could think, well, it's a trinomial and a is 1, so I can do the x method and think about what's going to multiply to be -6, but also add to give me -5. And I can think for a minute, and I get -6 and +1, because that will multiply to give me -6, but still add to be -5. So that's telling me how to factor. So if I come back, that's telling me that my factor form would be f of x equals x minus 6 x plus 1. From here, I could find the zeros, or which would be the solutions to the quadratic equation where you set f of x equal to 0, right? Because if we're finding the zeros, those are the places where the y value is 0 on the graph. So we're plugging in 0 for f of x, which is y. And from here, you're using the zero product property. And you're saying, okay, so that means that x minus 6 must equal 0, or x plus 1 must equal 0. And solving those two equations, I get x equals +6 and x equals -1. Now, if you notice, +6 and -1 were those same two values we saw on our graph, okay? So I'm trying to make this connection for you guys that the solutions to the quadratic equation, right? We have solutions algebraically, and those are giving us our zeros on the graph. So now we're going to look at some examples of polynomials. And what you're going to see is that the relationships between the factored form of a polynomial and its graph are exactly the same as the relationships we see in quadratics, because quadratics are just one subset of polynomials. So earlier this year, we looked at polynomials that were more in standard form, so something like f of x equals x to the 4th power plus 1, or g of x equals x to the 3rd plus 5x squared minus 2x. But the key would be that you also can have a factored form of a polynomial, and you don't necessarily know how to factor all more complex polynomials, but if I give you a polynomial in factored form, so for example, down here we have r of x is equal to 0.5 times x plus 3 times x minus 1 times x plus 4, okay? So if we start thinking about this, well, if I want to find the zeros here, or the solutions to when the y value is 0, or r of x equals 0. So I can set this equal to 0. And then I'm just rewriting the right-hand side of my equation. Now, since I already have factored form, I can skip right away to using the zero product property. I don't have to do any factoring. So I'm saying, okay, this means that x plus 3 equals 0, or x minus 1 equals 0, or there's a third case now that x plus 4 equals 0. So you need to solve each of these little mini equations. I'm going to do it in a different color just so we can see it. So subtracting 3 here, I get x equals negative 3. Adding 1, I get x equals 1. Subtracting 4, I get x equals negative 4. Okay, now if we slide over to the graph off to the left, we can see that, what do you know, those are exactly the places where this graph is crossing the x-axis. So we can see at 1, there's a 0. At negative 3, there's a 0. And then at negative 4. Now, one other connection I want to make for you guys is you can see the zeros on the graph show up directly in the equation. So you see negative 4 in this x plus 4 factor of the factored form, but the sign has switched, right? So if you're looking at the equations and you see an x plus 4, that's kind of cluing you in that you're going to have a 0 at negative 4. And the positive 1, we see the x minus 1. So again, the sign is switched. Negative 3, we have x plus 3. So I want to go over one more example with you guys before the end of this video. So in this last example, we are given a partially factored polynomial. So we have this function n of x equals x minus 3 times x squared plus 9x plus 20. So we have one binomial factor, which would be the x minus 3, and then we have a quadratic factor of x squared plus 9x plus 20. And we actually know how to factor that, right? Because that's a trinomial where a is 1. So we can do our little x method and think about what's going to multiply to be 20 and add to be 9. And we get, if you just think for a minute, I get 4 and 5. So that means that my factored form of this polynomial would be, I still have the x minus 3 that was given, but I have these two new factors to replace x squared plus 9x plus 20, which would be x plus 4 and x plus 5. So then from there I can set the equation equal to 0, use the zero product property. So that means either x minus 3 equals 0, x plus 4 equals 0, or x plus 5 equals 0. Which gives me x equals positive 3, negative 4, and negative 5. Now if you take a look, I put the graph of this function next to the graph, and you can see, or next to the problem, and you can see at negative 5, negative 4, and 3 are where the graph crosses the x-axis, right? So the solutions to the equation give you the zeros on the graph. All right, that's the end of this video. So you guys can try out the practice problems below, and we'll go over them in class tomorrow.